Okay, so now we're on compositions using equations. All right. So compositions using equations is a little bit fun, in my opinion. I think it's fun because I like to do mental math. If you don't like doing mental math, you may not consider this your kind of party, but it's okay. So there are a couple ways of evaluating. So when you're evaluating, option A is to evaluate the inner function first. Use this value, the first output, as the input for the second. That's option number one. Option number two, option B, is to write it in function notation and substitute and then evaluate. So it really doesn't matter which way you do it. We're going to model both, but one is you get a number first and then plug it in. The other one is you get another equation, a simplified equation, and then plug in the number. It's going to work out the same. We'll see which one we like. All right, so no longer with tables and graphs, we now have two functions. So f of x is 3x minus 5, and g of x is x squared plus 2. They're equations. You see them? All right, so these are our equations that we're working with. And our composition is g composed of f of 2. Okay? The first inner thing is f of 2. So our first input is going to be x equals 2, and it goes into f of x. All I'm doing is plugging in 2 wherever there's an x. Do we see that? 3 times 2 is? 6 minus 5 is? 1. So that result is now going to go into g of x, the second one. So we're going to plug it into the second one. Wherever there's an x, I'm now plugging in a 1. 1 squared is? 1 plus 2 is? And so our final output is 3. That is it. Was that terrible? All right, here we go. Are ready to do it? So we have f of x equals 3x minus 5. G of x equals x squared plus 2. We're finding the composition of g composed of f at 5. So where do we start at first? We start where? F. With what? We're going to plug in 5 into f of x, right? So I'm going to plug in 5. 3 times 5 is 15. 15 minus 5 is 10. Now this is going to be our next input for our second equation. And we're plugging that into g of x. Do we see that? So we plug that in. What is 10 squared? 100 plus 2. So our final output is 102. Yes? Okay, we're going to take away the chart. We're going to take away the mapping. So now, if you're given f of x equals x minus 5, g of x equals x squared, and it's saying g composed of f at -3. The first thing we're going to redo is just rewrite this. This is just a sentence. So it's saying g composed of f at -3. That's all it's saying. I used to call it Goff and fog because that's what it looked like to me as a kid. Goff -3. All right, so g composed of f at -3. So I'm going to start with the inside. What is my inside? F of -3. So I'm going to take whatever f is, and I'm plugging in -3. And what do we get? -8. So now I'm going to take -8 and substitute that in, right? So now we have g of -8. What is g? X squared. So we have -8 squared, which equals 64 is our final output. Inside to out. Inside to out. Yeah? Are you ready to try without me? Here's yours. Okay, so you have the same f of x and g of x, but this time you have fog. We did Goff, you have fog. So f composed of g at -3. Let me know if you need me.
I can do G first. You do your one line. Your first radius. And then you multiply 9. And then you do 9. So 9. And you get. We're starting. Any negative one. And then you would do it.
All right, are you ready?
It's literally this, that's the other way.
All right. So this time we had F composed of G at -3. So that means our inside is G -3, right? So we're going to start from the inside. We have G of -3. So G of -3 equals, remember when you are squaring and you have a negative, make sure you keep in mind that a negative times a negative makes a positive, okay? So now we're substituting that in, and we're left with F of 9. So I'm going to go to F, and that's 9 minus 5 equals 4. Yes? We survived. You survived compositions of equations. Oh my gosh. All right, so where are we at?
Another example.
Okay, make sure. So we're going to do another example of what if you have to do the same composition more than once. Well, if you do the same composition more than once, sometimes it's easier to create a whole new equation and then evaluate, okay? So we're going to model creating a whole equation. So for example here, we have f of x equals x squared plus 4x, g of x equals 2x plus 3. And we're going to be evaluating f composed of g at some numbers, right? So what we're going to be creating is f composed of g at any number. And if I put x, that means it can be any number. What that means is whatever g of x is, and what is g of x? 2x plus 3. So I'm going to substitute that entire expression. So we're substituting the entire g of x into your f of x. So wherever there's an x, it now becomes 2x plus 3. So our final is going to be 2x plus 3 squared plus 4 times 2x plus 3. That's what this becomes. All you did, wherever there's an x, whatever g of x is, you just turned it into your x. It's just substitution. Okay, so again, g of x represents the entirety of your unknown, correct? So what is g of x? G of x is 2x plus 3. Wherever there's an x, I am plugging in 2x plus 3. And so this is my new equation that I can use to evaluate every single time. So if I'm looking for f composed of g of 2, all I'm doing now is plugging in a 2. As the x. Instead of solving, I'm only now plugging in that value. So now when I evaluate, this is just going to be 2 times 2 plus 3 squared plus 4 times 2 times 2 plus 3. And now you're just going through PEMDAS. So we made one equation, and now we're gonna apply it multiple times. So we do the PEMDAS. PEMDAS says we start from the inside of the parentheses. 2 times 2 is 4. 4 plus 3 is 7 squared is 49. 2 times 2 is 4. 4 plus 3 is 7 times 4 is 28. So then our output is 77. Okay, because it's the exact same composition, I'm going to use the exact same rule again. Does that make sense? But this time, instead of just plugging in 2, we're plugging in 2.5. So we have 2 times 2.5 plus 3 squared plus 4 times 2 times 2.5 plus 3. And we're going to do again, PEMDAS it. What's 2 times 2.5? 5. What's 5 plus 3? What's 8 squared? All right, 2 times 2.5. 5 plus 3. 8 times 4. 32. So what's our final output? 96. Okay. So if you're using the same composition multiple times, sometimes it's easier just to create one equation, which is what your conclusion of what your discovery activity was from yesterday, is that if I'm trying to find the area, instead of doing it in 2 parts, I can do it in 1 part. And that's what the conclusion of that was. Okay. So, oh my gosh, guys. We have an X ticket, but we don't have time, do we? We'll do it tomorrow, but